Welcome to 6.2 Solving Trigonometric Equations Part 1, Example 4. Find all solutions of cosine x times the quantity cosine x plus 2 equals 1, where x is in radians. First, we might notice that there's going to be a cosine times another cosine, so this is actually quadratic in form. Therefore, we need to set it equal to 0 and try and factor. Before we set it equal to 0, let's go ahead and distribute the cosine x. Cosine x times cosine x gives us cosine squared x, and 2 times cosine x gives us 2 cosine x. So we get cosine squared x plus 2 cosine x equals 1. We need it to equal 0, so we will subtract 1 from both sides. Now we have cosine squared x plus 2 cosine x minus 1 equals 0. Because we have a trinomial with 3 terms, we have cosine squared x and a cosine x and a constant, we will first try and factor. So we're looking for two numbers that multiply to -1 and add to 2. The only two integers that multiply to -1 are +1 and -1. However, they do not add to 2. So therefore, this is not factorable. Since we have a trinomial that is not factorable, we will go ahead and employ the quadratic formula. If we have a trinomial of the form ax squared plus bx plus c equals 0, the quadratic formula gives us the solution x equals -b plus or minus the square root of b squared minus 4ac all over 2a. The trinomial that we have, we see that the coefficient in front of the cosine squared a equals 1, b equals 2, since that's the coefficient in front of cosine x, c equals -1. Looking at this equation that we have, we no longer just have an x, we actually have a cosine x as our unknown. Therefore, we're going to get cosine x equals -b, which is -2, plus or minus b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which is 1. I like to go to the side and figure out the number that ends up being under the square root and simplifying that square root. So 2 squared is 4, and then we get 4 times 1 times -1, so the minus a -4 turns into the square root of 4 plus 4, or the square root of 8. Now we can simplify the square root of 8. Since a perfect square goes evenly into 8, we can write that as rad 4, rad 2, since 4 times 2 is 8. So the square root of 8 is the same as 2 rad 2. Coming back, we have cosine x equals -2 plus or minus that big square root was simplified into 2 rad 2. And all of that goes over 2 times 1, which is 2. Since 2 goes in evenly to the whole number part, we could simply write that as -2 over 2 and 2 rad 2 over 2.
-2 divided by 2 is -1.
We bring down the plus or minus, and 2 rad 2 divided by 2 gives us just rad 2. So we get cosine x equals -1 plus rad 2, or cosine x equals -1 minus rad 2. I just move those two over to the right. Let's first look at cosine x equals -1 plus rad 2. First, I like to evaluate -1 plus rad 2 to see what kind of number we get. So when we plug in -1 plus rad 2, we get approximately 0.4142. However, we're going to keep that exact value in our calculator. Now let's think, which quadrants do we get cosine to be a positive? So that's going to be in quadrants 1 and 4. Now, in order to find the x value, whenever we have the angle inside a trig function and we want to find that angle, we have to find the inverse of that trig function to be able to find that angle. So x will be the cosine inverse of that 0.412, keeping all of those digits in the calculator. So if you already had this in the calculator, you could go ahead and do cosine inverse of your answer. Another option is just to find the cosine inverse of -1 plus rad 2. Either way, we get x is approximately 1.1437. So that's the angle in quadrant 1. However, we need another solution in quadrant 4. We know the reference angle will be identical of 1.1437. So now try and figure out how are we going to find that angle in quadrant 4. Notice in standard position we're going from 0 all the way around, but we're not quite getting to 2 pi. So to find that additional angle, we're going to do 2 pi minus that angle, which is 1.1437. Again, leaving those digits in the calculator for that calculation. So you could do 2 pi minus answer. So we get our other solution is 5.1395. So from 0 to 2 pi, we found two solutions. Now let's go over to cosine x equals -1 minus rad 2. Putting -1 minus rad 2 in the calculator gives us -2.4142. If we try and put the cosine inverse of -2.4142 and so on into the calculator, we get a domain error. And that is because cosine values can only be between -1 and 1. And this -2.42 is outside of the range of our cosine function. So therefore, this is not possible. We don't get any additional solutions from the part of the equation where cosine x equals -1 minus rad 2. Now we have to find the general form. Remember, we need to find the period of our function. So cosine x has a period of 2 pi. Therefore, when we go to write our general form, we write each solution plus 2 pi n. Therefore, our general solution is 1.1437 plus 2 pi n, or 5.1395 plus 2 pi n, where n is an integer. One last thing to check is that this is not duplicate information. If we are at the 1.1437 and we add 2 pi, we will get back to that same solution. So we don't gain this solution down here just by adding 2 pi. Similarly, if we're at this 5.1395 and we add 2 pi, we're going to end up back in that fourth quadrant. So we do need both of these answers for our general form. I hope you enjoyed this video. See you next time.